All right, in this video, we'll be looking at exploring the simulation on the Phet website about alpha decay. And so I've actually never been on this simulation before, and so we'll just kind of explore together here. The same advice that I've sort of given in previous simulation videos, I'll remind students up here, read all the stream, okay, RAS. So try to see everything that this sort of simulation has to offer. This is just my writing tool over here. We'll put that off to the side. All right, so it looks like we can, we're given a legend, and so in this simulation, the gray spheres are neutrons, the red spheres are protons, and alpha particles are 2 neutrons and 2 protons, right? So a helium nucleus. And then we have nuclei that we can choose from. So we have like polonium-211, that's going to lead-207, or we can like make a custom, nucleus down there. All right. It looks like we've got a bucket of plutonium, or just a bucket of atoms down here. If we're to sort of customize it, so let's stick with this polonium. Let's see, multiple atoms. And we've got a single atom. Okay. And so here we're sort of looking at the decay time, and it's going up about 5 milliseconds at a time. And as the polonium emits this alpha particle, you can see that it's decreased to 207, right? So it's dropped 4 units of mass. That's because the alpha particle has, 4 sort of nucleons, right? 2 protons and 2 neutrons. Note that it's dropped down to lead. Lead has 2 less protons than polonium, right? So as that polonium undergoes this alpha decay, it actually transmutes to a new chemical species, lead. And you can see that it sort of stopped here at 100 milliseconds, about the time it might take. And then we see like a half-life here on this chart. We're going like from 211 down to 207. I think that's the end of this simulation. Let's go to multiple atoms here. Let's reset all the nuclei, add 10, 20, 30, okay. So we've got 30 nuclei. We got a bucket of polonium. I might have said plutonium earlier. My bad, everybody. So polonium. All right, now let's hit play. So it looks like, all right, we got some nuclei, and then this guy over here emitted an alpha particle. This guy emitted one. So we see these. There's a sample of polonium, right? But because the polonium is radioactive, it's going to undergo this alpha decay, and so we see all these sort of alpha particles being emitted. And then on the chart up here, you can see that some of these have dropped down to 207. Again, you're seeing that. So the total amount of polonium that we have is decreasing, right? So we've got sort of not polonium anymore, but rather this lead. All right, and so it should be, we got about 15, right? So they're marking the half-life right here. And so if we were to count them, at that time, there might have been, that sort of 15 polonium still and 15 lead. And so this is time in seconds. You can see it took about half a second for the half-life there. After 1 second, that's another, half-life, and so on. And so that's really all that there is to this simulation. Reset all the nuclei, right? We can add more, it's like a big sample, and we'll just see that, the same thing is true. It's just gonna, because each individual atom is undergoing this sort of, spontaneous sort of random decay. It's not going to matter how many we start with in terms of half of them will be gone after, sort of the half-life. And so if we start with 50, we'd expect 25, to still be polonium after half of a second, All right, let's take a look at, let's reset all nuclei. Yes, reset all settings. And we'll go to our custom